Welcome! This video examines the most common LAN technology used today, Ethernet. Since its inception in the 1970s, Ethernet has evolved to meet the increased demand for high-speed LANs of today. The continued popularity of Ethernet is due to its simplicity, reliability, and low cost of installation and upgrade. Ethernet has responsibility at the lower two layers of the OSI model, the data link and physical layers. At the physical layer, Ethernet involves signals and bit streams that travel on the media between communication devices, playing a key role in connecting all end devices that operate on a local area network. Ethernet divides the data link layer into two sublayers, logical link control and media access control. At this layer, Ethernet is only implemented on the MAC sublayer. Let's review the functions of the logical link control sublayer. The LLC's primary responsibility is to communicate with the upper levels of the OSI stack by handling the communications between software and hardware. The LLC sublayer takes network layer packets from layer 3, identifies the protocol, and then encapsulates the packet with control information, thus creating a layer 2 frame, and sends it to the MAC sublayer. An important feature of the LLC sublayer is that it is implemented in software and thus independent of physical equipment, increasing Ethernet's capability to be compatible with many different types of media. After the LLC processes a frame, it sends that frame to the lower data link sublayer called the Media Access Control sublayer. This sublayer has two primary responsibilities: getting data on and off the media, and data encapsulation. To understand how data is placed on and removed from the media, we must first understand that Ethernet is a multi-access bus, meaning that all devices on a network share the same medium, as illustrated in this video. Because of the potential for congestion and to avoid collisions, the MAC sublayer must dictate when to send and receive data. Ethernet uses a method called Carrier Sense Multiple Access with Collision Detection, or ccna to do this. This method performs as its name implies because it senses when the network is being used and waits until the network is not in use before sending a frame. This method reduces the chance of collisions of frames on the network, as there is only one frame on the network at a time. If a collision does occur, a jam signal is sent, and each device calculates a back-off algorithm before returning to the listening before transmitting mode and attempting to transmit again. The second function of the MAC sublayer is to encapsulate data. When encapsulating data, the MAC layer adds header and trailer fields around a layer 3 data packet to create an Ethernet frame. The frame is the PDU at layer 2. The beginning of the frame, the preamble, and start frame delimiter are fields used for synchronization between sending and receiving devices. Essentially, the first 8 bytes of this frame is used to alert the receiving devices that data is following. The destination address and source address fields are used to identify the physical address of the destination and source devices, both of which are represented with 6-byte numbers. The length field is used to indicate the exact length of the frame's data field. This number is represented with 2 bytes and is used later in calculating the frame check sequence to ensure that the message was received properly. The largest field is the data field and contains the encapsulated data packet from layer 3. This field can range from 46 to 1500 bytes depending on the size of the packet received from layer 3. The last field is the frame check sequence field, represented in 4 bytes. This field is used to detect errors. The destination host calculates a frame check sequence for the frame and compares it to the frame check sequence sent in the frame by the source device. If the calculations match, no error has occurred and the message is a success. Calculations that do not match are an indication that the data has changed, therefore the frame is dropped. The frame check sequence is a useful tool provided by Ethernet to ensure accurate transmission of methods across the physical media. As you've seen, the MAC sublayer is responsible for many crucial operations when sending and receiving data through the physical medium. Let's look at how the assignment of the physical address, also called MAC address, to layer 2 frames occurs. Unlike IP addresses that are assigned by network administrators, MAC addresses are permanent and unique to every device. No two MAC addresses are the same. An IEEE standard ensures a unique physical address for every Ethernet device. The rules require vendors that sell Ethernet devices to register with the IEEE. When the vendor registers, they are assigned a unique identifying number known as an OUI. IEEE requires the vendor to follow two simple rules. First, that all MAC addresses assigned to the NIC or other Ethernet device must include that vendor's OUI as the first 3 bytes. For this example, the vendor is Cisco. Second, all MAC addresses must be assigned a unique value or serial number in the last 3 bytes. You've seen how Layer 2 Ethernet functions. Let's overview the physical standards. Ethernet is covered by the IEEE 802.3 standards. 4 data rates are currently defined for operation over optical fiber and twisted pair cables. These are 10 megabit per second, called 10 base T Ethernet, 100 megabits per second, or fast Ethernet, 1000 megabits per second, or gigabit Ethernet, and 10 gigabits per second, or 10 gigabit Ethernet. You see that each of these flavors of Ethernet can be implemented over different physical media, and each has different characteristics and limitations. A network engineer needs to know which implementation is best under specific network situations. Generally, because of cost, copper is used within buildings at the access layer, and optical fiber is used between buildings and for horizontal cable runs. Clearly, since Ethernet is the most popular LAN protocol in use today, a network engineer needs to understand the functions of the Ethernet protocol at the data link and physical layers of the OSI model. Practice setting up Ethernet LANs so you can improve your Layer 2 and Layer 1 troubleshooting skills.